Alright, welcome you guys to section 6 of our preview chapter. This last review section is going to take us through the rectangular coordinate system in graphs. So I think you're going to recognize a lot more of this section than you have maybe out of some of the other ones. First thing that we're going to review is the Cartesian plane. That's the grid that we do most of our graphing on. Copy down the following slide with its labels. So you don't need to make all of the crisscross lines, just give yourself the x-axis and the y-axis on your paper. You don't even necessarily need to add the numbers that are on my picture, but quadrant 1, quadrant 2, quadrant 3, and 4, remember they go counterclockwise around the graph starting in the upper right corner. They are numbered with Roman numerals, not regular numbers. Also label the x-axis, the y-axis, and the origin. Those are the main points that we need to remember about how our grid, Cartesian plane or our grid is laid out. Now each coordinate is an x, y point. Points always come in this order, x then y. You always graph it, going along the x-axis for the x-coordinate and going up or down the y-axis for the y-coordinate, which makes perfect sense. Okay, so take a look at that first point that I put on the slide here. I gave you point A as -3, 2. So to graph that, go backwards on the x-axis, -3, because the negative direction is to the left. My second number I gave you was a 2. The y number, therefore, is 2. The +2 direction for y is up, so I go up 2. So left 3, up 2, you can see where A is on the chart. B, I gave you one where one of the coordinate pieces was a 0. These seem to be the most difficult ones for kids to graph. They end up doing them backwards. You have to keep yourself focused about which number is which. The x number is first. It counts off in the x direction, left or right. So if the first one is 0, you are not moving to the left or the right. Then the second number is still the y number. It tells you to go down 5. Okay, so notice where B sits on 0, -5. And then C is the 0.14, and I think that one probably you are okay with. Scatter plots. These are a form of graphing that are used actually quite often, and it's just a graphing of all kinds of different data points. So when you have, anything like a height and weight, or data that might be revenue and expenses, they can be graphed. When things come in pairs like that, you can graph them as an ordered pair. So then the entire group of those things graphed form a scatter plot. Okay, scatter plots are used to find trends. Sometimes they're used to find that there is no trend. If you get all your dots graphed onto a grid and they're just all over the place random, there's just no trend in the data, and sometimes that's a useful thing to know. So take a look at page 52. The book gives us an example of one. I was not going to try in my PowerPoint here to recreate one, but you can see the table has years and it has subscribers in it. The first column of a table you should always assume to be the x coordinate. Okay, it's just like our XY tables when we set them up. So the year is our x coordinate and the subscribers is our y coordinate. So notice the graph. Years are laid out along the bottom of that grid, and subscribers go up the side, just like your x-axis and y-axis do. Then each of those is simply graphed like you would graph any other point on a Cartesian plane. When you look at this one, there is a definite trend to this data. See how it climbs to the right? It's called a positive correlation. Okay, as one thing gets higher, the other one gets higher. Data that trends down has a negative correlation, so that when one of them gets higher, the other one gets lower. All right, so this was called a positive correlation that's pictured in example number 2. If it would have kind of trickled downward, it would have been negative correlation. If it's all over the place, that's called no correlation. This next piece up here should look pretty familiar. You guys have worked with the distance formula plenty through Algebra 2. I'm not a huge person about memorizing, simply just because the distance formula can be derived from Pythagorean theorem if you need to, or a simple sketch of 2 points turned into a right triangle, you can just flat out use Pythagorean theorem yourself. Okay, so let's take a look at how these two things are connected. All right, so hopefully on this next slide you recognize Pythagorean theorem that I have typed. Now, if we were going to solve for c, okay, right now we have c squared up in our equation. Now, if you remember, the process to unsquare something, hang on, my marker is very off. I need to align it here quick. I don't know if this is recording or not, but be patient. All right, we'll see if that helped. If you want to unsquare something, you take the square root of it. We also know from our equation solving days that what we do to one side of an equation, we have to do to the other side of the equation. Okay, so the square root of c squared is c, and the square root of a squared plus b squared is going to match our distance formula. Okay, a is the length of a triangle side, b is the other length, and c, of course, is our hypotenuse. Well, the distance along a from point to point, okay, you would take your x value of each of those points along a and you would subtract them, correct? Okay, so the x from one point minus the x, I guess that's a 2, I'll just make it match, can be substituted for a. Now the distance b here, from down here to up here, that's the change in your y values. So let's switch out b for the y value of one of them minus the y value of the other one. And now you're looking at the distance formula. Okay, so Pythagorean theorem and distance formula, they are the same thing. If you remember one better than the other, no sweat. You're going to be able to solve any distance between 2 points problems. If given 3 points, you can see if they form a right triangle by using the distance formula on all pairs of points, and then insert the 3 distances into Pythagorean theorem and see if you end up with a right triangle. So, if we were to look, if we were to look at problem number, or example number 4 at the top of page 54. Let's walk through this one. Okay, so in this, gives us the point 2, 1, 4, 0, and 5, 7. So let's find the distance between these two first. So square root of 4 minus 2 squared, those are the x terms, plus 0 minus 1 squared is the square root of 4 plus 1, or the square root of 5. All right, so that's one distance. Now let's find the distance between the second and third point. So we would have 5 minus 4 squared plus 7 minus 0 squared, which is 1 plus 49, or the square root of 50, right? Then the other 2 points. We'd have the first and the third one we have to find the distance between. Sorry I couldn't talk through that. I'm sure you didn't really mind, but my microphone wouldn't reach that far. So we have one triangle leg that's root 5. The other leg of the triangle has to be the root 45, correct? Because we know the legs are always going to be shorter than the hypotenuse. So that leaves root 50 to be our hypotenuse. Now, Pythagorean theorem we know is this. So let's put one leg here, the other leg here, and the hypotenuse here. So root 5 times root 5 is 5. Root 45 times root 45 is 45. And root 50 times root 50 is 50. Well, 5 plus 45 is 50, so this one would in fact be a right triangle. Midpoint formula. This is another one I never got real hung up on making people memorize. The midpoint is the middle of 2 points, correct? Well, finding the middle of 2 numbers, we just average the 2 numbers, correct? So if you look at that real close, isn't that exactly what we're doing? You take the 2 x values from the 2 points, add them up, divide by 2. That's finding an average. You take the 2 y parts of the points, and you average them as well. To me, that makes perfect sense that by averaging the x's and averaging the y's, you are going to get into the middle of the 2 points. So let's give this one a try on paper. Let's find the midpoint of these 2 points. So the x's, -2 plus 4, let's average them. So we end up with 2 over 2 or 1. The y values, 8 plus a -10, sorry. 8 plus -10 is -2. -2 over 2, -1. So 1, -1 should be the midpoint between those 2 points we started with. And if you look at the numbers, it makes sense. That does look like it should split the difference between them. Now, page 55 has a couple of application problems for us to take a look at. Finding the length of a pass of a football. Okay, all it's doing is implementing the distance formula to find the distance between the pass that started on the 28-yard line and went 40 yards from the sideline, and one that the pass was on the 5-yard line and 20 yards from the same sideline. So you can see those 2 points that it gives you on the grid. So we've got a 40-28 point and a 25 point, and it's just following through their process on the distance formula. Okay, estimating annual sales. It gives you the sales in the story problem for the year 2009 and the year 2011. And they're asking you to predict the sales for the year 2010. Well, that is right in the middle of the 2 years they gave you. So they are suggesting that the amount of sales then might be right in the middle of the 2 amounts of sales for those years 2009 and 2011. So it's a midpoint problem. Okay, so 2009 it was 11.7. And no, 9.8 in 2009, excuse me, and 11.7 in 2011. Those are your x and y coordinates. Find your midpoint and you've got your estimated sales. They're estimating 10.75 billion. Okay. Last thing for this review section is a translation. Now, the common term for translation is to slide an object. All right, we did these way back when, and I think you did them again in geometry class. Not quite positive about that or not, but we're going to slide the object. The key thing to remember is that you must take each vertice, each point of the figure, and move it the same amount in order to retain its shape and size. When we translate something, it still looks exactly the same when we're done. It hasn't rotated, it hasn't flipped, it hasn't done anything else. It's just slid. Now, we should be able to come up with new vertices without even graphing it on graph paper. If given a parallelogram with vertices 1, 4, 3, 6, 3, 2, and 1, 0, find the new vertices after translating the figure 2 units right and 1 unit down. Well, 2 units to the right, does that affect your x value or your y value of your point? The left and right movement is your x value, correct? How about the 1 unit down? that's going to affect your y value. So take each of these points and do those things to it. So we're going to add 2, excuse me, the right is the positive direction, add 2. Now 1 unit down would be to lose 1 on the y column. So my new vertice here would be 3, 3. Here, 5, 5. 5, 1. And 3, negative 1. Okay, and if you did actually create that picture on graph paper, that should be where you end up unless we mess something up. Okay, so the translations are pretty straightforward. Might be the easiest thing we've done in days. All right, there you go. That's it for me for today. Come back on Monday if you have questions on this. Hopefully you're watching this over the weekend and don't have to burn up any of class time Monday doing it. All right, see you guys soon. Bye.